All right, so this is Project 1 for Fundamentals of Aerodynamics with Dr. Ozbay, which is a 2D wind tunnel simulation. So we are given a couple of specifications, including the settling chamber area, the height, contraction length, the test section length and height, and the diffuser half angle and length. We're also given an equation to find the test section velocity given the fan frequency. Um, we are required to do three different conditions: 20 hertz, 40 hertz, and 60 hertz. For this video, I will be doing 60 hertz to run the simulation. We are also required to get velocity, static pressure, total pressure, dynamic pressure, contours, and get the plots after we export the data into Microsoft Excel. So yeah, let's get started. So I already have Workbench open up, and we have a blank canvas that we can work with, and I'm just going to drag and drop. First thing we are going to do is click on geometry and switch this to, switch this to a 2D analysis, as this is a 2D analysis. All these other properties we can keep the same, and we're going to double click to open up our geometry tab that will allow us to create our wind tunnel sketch. So we're going to be working primarily in the XY plane, as it's the easiest. We can switch this to sketching. First thing I'm going to do is set this to inches, given that our dimensions are giving to us in inches. We'll have to switch it to meters later for our center line, but we can worry about that later. What we're going to do is start off with our line and create just a general line. And first thing I'm going to do with this is constrain it to our midpoint by clicking the line and clicking the center point. I will dimension the line, that way we have a general size for our inlet. This is going to be our inlet. So if we go back to our document, settling chamber has a height of 22 inches. So I'm going to have to zoom out for that. And now we can start modeling the rest of the wind tunnel. So what I'm going to do is just draw a bunch of lines in the general shape of a wind tunnel. So we have our contraction chamber, our nozzle, our test section, and lastly our diffuser. And I'm going to do the same thing on the other side. It's a horribly drawn wind tunnel, but we will dimension it to make sure everything is correct. So now we can dimension everything. So we have our settling chamber with a height of with a length of 15 inches. Sorry. So I'm going to constrain both of these to be 15. Now our contraction chamber has a length of 24 inches. We're going to switch that. And then our test section has a length of 12 inches. And then our test section has a center line, has a height of 6 inches. So our center line is going to be 3 inches. So there should be 3 inches of space. We're going to switch it to the vertical. Should be 3 inches. So that way this total height is 6 inches. And then lastly, well, not lastly, we are going to dimension this. Has a length of 42 inches. Our diffuser. And then we need our angles. So our diffuser has a half angle of 3 degrees. So 180 minus 3 is 177. Whoops, I set that in the wrong direction. There we go. And then this one. Whoops, once again set it in the wrong direction. And then lastly, we need our outlet. And then we have our body. So now that everything is in all dark blue, that means we are fully constrained. What we're going to do next is surface, because we want to create a surface from this sketch. We're going to hit sketch, apply, and then we should be good to generate. There we go. Now we have a surface from our sketch for the wind tunnel. We can file, save project, just so that we don't lose it. Desktop, Aero project 1. Video. That way everything is saved. Save, and I'm going to close this out. That way we can save some computer space. Next up, we are going to be creating our mesh, which is what will allow us to actually calculate properties along every part of the wind tunnel. I'm gonna double click that, and that's gonna take a second to open up. And while this loads, I'm going to talk about our velocity. So I used this equation to find the test section velocity at 60 hertz, which came out to be 14.56 meters per second. And then using diffuser area and contraction ratio, I found that the velocity at the inlet would end up being 3.97 meters per second. And that is the equation we will be using when we set up the inlet velocity. All right, so now that this is opened up, we can generate our mesh. What we're going to do is method. We are going to select this as our geometry, our face. Apply. And then what we're going to do is change the method. We're going to use triangles. After that, I believe we could generate the mesh. And then after that, the mesh. Okay, so it created our mesh. Now, this is good. It's not great. We want a bit more triangles to have a more accurate reading on all parts of our wind tunnel. So what we're going to do is switch the element size to 0.01. And then we are going to generate. And now we have a lot more triangles, which will give us a lot more room to work with in terms of more accurate simulations and data. Next, what we are going to do is that we are going to so next what we're going to do is select a bunch of our wall faces and create a group selection name. We are going to name this wind tunnel wall, and then select this one and hit N and hit inlet. Select this wall and hit N and select and name it outlet. All right. Now we have everything selected. And I'm going to save this. This should be good. And now I can click out of here. I am going to update it. That way it has the most up-to-date mesh. Now that this has the most up-to-date mesh, we are now good to do a setup. We're going to do double precision and 2 solver processes. This is going to bring up our Ansys workspace. All right. So there will be a couple of things that we have to set up before we can run our simulation. So this is our wind tunnel. So what we're going to do is we're going to set our energy equation on. Hit OK. We're going to set our viscous model properties. We're going to do a K epsilon. This is standard. Enhanced wall treatment and pressure gradient effects and thermal effects will be turned on. Hit OK. And then what we can do is boundary conditions. We can set our velocity magnitude using this menu. As I explained earlier, I found that our velocity was 3.97 meters per second. 97. We'll do 1.5 for a bit more accuracy. Apply. And then I believe we can run our calculation. I'm going to set this to 150 iterations. Anything a lot higher than that might take longer, might be too much for your computer to handle. Anything less than that, you might have less accurate data readings. Then we're going to hit calculate, and it is going to run. These graphs, I'm not really sure what they do, but now our calculation is complete, and in order to get the data that we want, we can look at the different results. So open up graphics, double click on contours, and you can see all a bunch of different values. So we want pressure, density, all those different things, but for now we want pressure. We can see our static pressure contours. Whoops, sorry. We can see our static pressure. We can see our dynamic pressure. We can see our total pressure. A lot of pressure, except for at the walls. And then we can see our velocity magnitude. Not very fast here, but then it picks up during the test section, and then slows down in the diffuser. Now, we wanted also the plots. So what we can do is open up plots, XY plot, and then we can create a new surface because we want our data at the center line. So what we're going to do is line. So we need our x1 in meters. So what we're going to do is go back into our geometry. And then what we're going to do is use our tools. First thing we're going to do actually is set this to meters. Tools, analysis tools, distance finder. Going to switch this to our edge. Select this edge. And then select this edge. Apply. 2.3259 meters. Meters. I typed that in 2.3259 meters. Perfect. Close that out. Hit create line 6. I'm going to actually rename this to center line. Create. And then we're going to hit our center line. And if we want to write this to our Excel file, what we can do is hit write to file, hit write, and then save it. It will save as its own file. So for the sake, I'll just do document. I'll save it to my desktop. Aero project, and then you can name it whatever. So what you're going to do in order to import it to Excel is export it to this folder. So let's say I name this to static pressure video. Hit OK. And I go into the folder, static pressure video. What you're going to do, hit open with Notepad. And then these are all of our data points. And then what you can do is paste this into Excel and then create the contours, create the graphs in Excel. Or if you wanted to see them in Fluent, what you can do is deselect write to file, make sure center line, and then plot it. And it'll show you a plot for static pressure, a plot for dynamic pressure, a plot for total pressure, and lastly, a plot for our velocity magnitude. And then, as I said, these graphs, not really sure what they do. I'm sure in our next project they will be important. But for now, this was the tutorial on how to create a wind tunnel, get the contours, get the plots for Professor Ozbay for our Project 1. Thank you.